I was asked to explain the different quantities on page 192 in your textbook to give examples of vectors and scalars. So that's what this video is about. I think the problem is that quite a number of those quantities you don't know. So let's look at the scalars. Now, scalars are quantities with only size. If you want to use simple English, magnitude if you want to use the scientific English. Now, mass is the first one that they have given on page 192. Now, mass is just a measure of the amount of matter in an object. There is only size connected to this. So your mass has no direction connected to it, like 2.5 kgs of sugar on Earth will be 2.5 kgs of sugar everywhere in the universe. There's no direction connected to it. Next, they say an example is speed. Now, speed is by definition the distance traveled per unit time. So speed is distance over time. Now, to explain distance is path length. And time is the third dimension of, or the fourth dimension of life. So you can be living here, but you are living for a second or 2 seconds or 2 years. That time is has only size. There is no direction connected to size. There is also no direction to path length. So path length is also a scalar. No direction connected to time, so it is a scalar. Some people might argue, yes ma'am, but 100 years ago is in the past, but there's no direction to the past. 100 years from now in the future, people would think that there is direction to that, but your future there is no direction to time in future either. Oh my, I hope I didn't confuse any one of you now. So there is, if I can use an example, I take about 15 minutes, which is 0.25 hours, to travel 9 kilometers to school in the morning. Now, I don't get into the car and go straight to school. The road makes turns and there are stops, and I have to change direction all the time. But this is my path length. 9 kilometers. So my speed would be 9 kilometers divided by 0.25 hours, so it will be 36 kilometers per hour, or we could say kilometers hours to the power negative 1. So speed is also a scalar quantity. The third one they measure wavelength. Now by now you should know what wavelength is. It is the distance between two consecutive points in phase. So distance is a scalar. So wavelength would be a scalar quantity. Okay, next one is energy. Now energy is the ability to do work, and there is no direction connected to that. If it says that you have 5,000 kilojoules in 100 grams of food, that is the energy that you have in that 100 grams of food, and there's no direction connected to it. Energy is the ability to do work. 5 is power. Now power is the rate at which work is done. So if I can use the equation, power is work over time, and work is the change in energy. So there is no direction to power. So power is a scalar because there is no direction to it. The change in energy is a scalar. So work is also a scalar. Right, there's no direction connected to it. Next, they said electric current. I can't remember which number, 1, 2, 3, 4, 5. Number 6, electric current. Now, electric current is the charge per time. It's the rate of flow of charge. Now, charge there is no direction connected to electric charge. It's your electrons flowing. But there's no direction to, sorry, it's the number of electrons flowing. So there's no direction to a number of electrons moving. And the unit time is a scalar. So electric current is a scalar. There's no direction connected to it. Next is electric potential difference, or voltage is electric potential difference. So electric potential difference is the work done per unit charge. Now we have discussed work done is a scalar and charge is a scalar. So voltage is also a scalar. Last one is coefficient of friction. Now this takes you into grade 11, sorry about that. But the coefficient of friction is a ratio between the frictional force and a normal force. Now, this word normal refers to mathematics perpendicular. So, if you have something that is resting on a surface, like this block is resting on the surface, the normal force will be the force of the surface on the block, and we give it the symbol Fn. Okay. Friction is the force opposing motion. We've discussed that in grade 9. I have to stop this video here and then I'll do a second video to explain vectors.